Now we're going to look at the practical side of multi-threading, that are thread libraries. These are the toolkits that programmers use to actually create and manage threads in their application. A thread library provides a programmer with an API, an application programming interface for creating and managing threads. There are two main ways to use these libraries can be implemented. One, in user space, where the library functions are fast, local calls with no kernel support. Second, in kernel space, where the library is supported directly by the operating system and API calls become system calls to the kernel. As the slide shows, the three main thread libraries that are used day to day are POSIX Pthread libraries, Win32 threads, and Java threads. Let's start with Pthreads. This is the POSIX standard that defines a specification of thread behavior, not a specific implementation. It's common on Unix-based systems like Linux. Key features are global variables are shared among all the threads in the same process. A parent thread can wait for child thread to finish before it continues an operation known as joining. Pthread always begin their execution in a specific function that the programmer defines. We will look into more details in the later example videos. Next, we have Java threads. All thread management in Java program is handled by the Java Virtual Machine. The JVM typically implements Java threads using the native threading model provided by the underlying operating system. So, on a Windows system, Java threads are usually Windows thread, and on Linux they are pthreads. They, there are two primary ways to create thread in Java: by extending the thread class or by implementing the runnable interface. The standard and most common practice is to implement the runnable interface. This is more flexible as it allows your class to extend another class while being runnable. The runnable interface is simple. It just requires you to define a run method which contains the code your thread will execute.